Okay. Now let's do this one. Y equals sine of x plus 2. X is from 0 to 3 pi over 2. And y equals 0. And we want you to rotate this about the x-axis. Okay. So let's take a look at our region. Y equals sine x plus 2. It's the regular sine x curve moved vertically up 2. Normally starts at 0, so I'll start at 2. I'll go ahead and put pi here. I'll put 2 pi here, which means this is pi over 2, and this is 3 pi over 2. So we've got, so this is pi over 2, this is pi, and this is 3 pi over 2. Well, touches 0 here and 0 here, so it goes up by 2. At pi over 2, it goes up to 1, so now I'll go up to 1, and then I'll drop down here, 1. So my function is going to look like this. This region I'm going to rotate around the x-axis. Therefore, I'm going to get a region that looks like this. That's my solid. Okay. Well, my solid, I'm going to take a slice of that solid. I'm going to turn it around. This is going to be my circle. This point is the x-axis. This height is my function. If I go out x, my height is going to be sine x plus 2. So in this case, my radius equals sine x plus 2. Well, 0, 3 pi, lower limit, upper limit. I didn't have to worry about where, setting functions equal to each other to find the x value. I was given the x values explicitly. So in this case, the volume is equal to the integral from 0 to 3 pi over 2. Let's make this a little more clear. To 3 pi over 2 of the area of x dx, which is equal to the integral from 0 to 3 pi over 2 pi times sine x plus 2 squared, because r is this, is pi r squared, times dx. I get pi times the integral from 0 to 3 pi over 2 of sine squared x plus 4 sine x plus 4 dx, which I can separate out into pi times the integral from 0 to 3 pi over 2 of sine squared x dx plus 4 times the integral from 0 to 3 pi over 2 of sine x plus 4 times the integral from 0 to 3 pi over 2 of dx. Sorry, dx. 3 integrals. Okay. Now, at this point, again, it's best to just go ahead and use your calculator if you can. But if you can't, if, for any reason on the AP exam, this is the part where you're not allowed to use the calculator or your teacher is not letting you use the calculator, you're just going to go ahead and solve these integrals. Now, let's go ahead and deal with these integrals one at a time. Okay, so the first integral, our first integral was pi times the integral from 0 to 3 pi over 2 of sine squared x dx. Okay, this particular type of integral you haven't met yet, and it's part of a future unit that we're going to be discussing called techniques of integration. So when we deal with certain types of trigonometric integrals. However, I'm going to go ahead and do it for you now, but realize that if you come up with something like this in the problems, just go ahead and use your calculator, because the particular techniques for solving this type of integral you haven't learned yet, but you will very, very soon. So I'm going to rewrite this as pi times the integral of 0 to 3 pi over 2 sine squared x. There is an identity where sine squared x is actually equal to 1/2 1 minus cosine 2x. So wherever I see this, I'm just going to put that in. So it's going to be pi times 1/2 1 minus cosine of 2x dx, which is equal to pi over 2. I'm going to pull the 1/2 out. 0 to 3 pi over 2 dx. I'm going to separate these out. Minus pi over 2 times the integral from 0 to 3 pi over 2 of cosine 2x dx. And what I end up with here is pi over 2 times x from 0 to 3 pi over 2 minus pi over 2 times the integral is going to be 1/2 of the integral of cosine is going to be, yes, 1/2 sine of 2x evaluated from 0 to 3 pi over 2. I will go ahead and let you take care of that. That's going to give you some number. That's the first integral. The second integral, the second and third you can deal with. That's not a problem. So the second integral, let's just go ahead and go through it. We said that that was 4 pi times the integral from 0 to 3 pi over 2 of sine x dx. That is just going to equal 4 pi times minus cosine x from 0 to 3 pi over 2, and that's going to be some other number. I'll call this A, I'll call this B. That's the second integral. Whatever it happens to be, I won't worry about evaluating it. And the third integral, also something that you can do. That was 4 times the integral from 0 to 3 pi over 2 dx. That's equal to 4 x evaluated from 0 to 3 pi over 2. This one is easy. This is just 6 pi. Therefore, our final volume, we're just going to add up the a, b, and the 6 pi. So it's going to be a plus b, whatever you got, plus 6 pi. That's it. Again, the whole idea is based on finding the solid, taking a slice, turning that slice around. Once you've turned that slice around, find what the radius is, set up. The area is nothing more than pi times the radius squared. It's going to be some function of x, and therefore the volume is just going to be the integral from a to b of pi of a of x dx, and the rest is just solving the integral. I'm going to go ahead and actually stop just with those 3 examples. I hope that that made sense. The pattern is the same as you see. We break things up into little bits, we analyze that little bit, and then we integrate all of the little bits. That's the whole idea behind the calculus. Calculus in Latin means little stone. So if you want to find out what the weight of a big stone is, you break up the big stone into a bunch of little stones, you add the weights of the little stones, you add them all up, that gives you the weight of the big stone. That's why it's called calculus. Okay, thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.